Welcome to classes on inorganic chemistry, and it is a topic on the structure of atom chemistry, higher secondary first year, and class number 19. And this chapter is very important for class as well as entrance point of view. A lot of small questions are there, very often asked in the entrance exams, also in the class exam. So you minutely follow the classes, and this class is too much informative one. So structure of atom means how an atom is composed of and what are the things or material found in atom. So the first concept was given by Dalton. Very simple definition. There is no complexity in the definition. That every matter in this universe is consists of extremely tiny particles which takes parts in the chemical reaction, and it cannot be destroyed nor can it be created. This is very simple concept proposed by Dalton in 1808, and later on a lot of other things included in atom, as it was the first concept. Hence, for his honor, the concept of atom as proposed by Dalton is still in the chemistry first part. Now let us explain some of the compositions of atom before going to elaborate, that is subatomic particles in atom. What are the fundamental subatomic particles of atoms? First one is proton, designated by this or this RP. Discovered by Goldstein. It is positively charged particle found in or resides in nucleus. So very simple. Very simple information regarding protons are: proton may be designated at 1H1 or H plus or simply P, and it was discovered by Goldstein, and it is positively charged particle resides or found in the nucleus. It is a part of nucleon, and its mass of the proton is 1.672 into 10 to the minus 27 kg, and in terms of atomic mass unit is 1.00728 atomic mass unit. And it is also these positively charged particles, when are also called canal rays. Again, electrons which is designated as -1 E naught means it is atomic number and is mass number. Atomic number is -1. You will get it later on. I will explain. -1 and mass number is equal to 0, and it is discovered by J.J. Thomson, and it is the constituent of cathode rays and or beta rays or beta particle, and its mass is 1.674. Here 728 is 74, a bit heavier than proton, 10 to the 27 kg, or 1.00. Here it is 728. Here it is 89 AMU. Am I right? And also this positively charged particle when comes out from the cathode ray, this negatively charged particle when comes out from the cathode ray in the discharge tube, in the vacuum discharge tube, it is called cathode rays. Next is neutron. And also mass of electron is 1 by of proton. Very often short question appears in the exam. The mass of electron is equal to 1 by 1837 of proton, and it is cathode ray as it's emitted out from the cathode in a vacuum tube. So another new term, nucleons, you will very often come across with the term nucleons. Nucleons means proton and neutron when they are found in the nucleus. So in combined proton and neutron in the nucleus is called nucleons. It is very important term you need to know. So these things may not be known to you, just you keep knowledge, because in case of the nuclear reactions or a chapter is there in the physics second year nuclear chemistry, you will come across with these terms. So other fundamental particle besides proton, subatomic particle, proton, electron, neutron in the atom, there are some other positive other particle which very often appears in the atom, especially in the nucleus. There is some interchange of proton and neutrons. When we will explain the stability of the nucleus in the chapter physics, I have already explained in the second year. You may check this topic in higher secondary physics second year, nuclei, chapter nuclei. The one other other fundamental particles are positron, and which symbol is E plus or plus 1 E naught, or proton simply, or neutrino. It is chargeless and massless. It is designated as gamma, and antiproton is equal to P of negatives and positive positive mu mesons and negative mu mesons, positive pi mesons, negative pi mesons, neutral pi mesons, epsilon mesons, and bosons. A lot of other summative other particles. Very often you will come across with these terms. Just for your knowledge, I have given fundamental particles. Atomic number, mass number. I will not go details about these things. You have already got these things, and just the symbol or representation is need to be known for you, are known to you. So atomic number, it is designated by Z, and mass number is Z. Say it is an element which atomic number is here and mass number is here. So atomic number is this. Say for example, carbon. If you assume carbon, it is atomic number is 6 and mass number is equal to 12. That is, for carbon, this is Z and this is A. Just you should know these things, atomic number. So atomic number is nothing but the number of the proton in the nucleus, and for the neutral atom, number of proton is equal to electron. So number of proton in the nucleus is called atomic number. What is mass number? Mass number is number of proton and neutron. Number of proton in the nucleus, proton and the neutron in the nucleus is called mass numbers, and this mass number is represented by A. From this mass number, you can find out number of neutron. If it is the mass number is given, a number of proton is given, so you can find out neutron. So mass number is nothing but A, and which is designated as the sum of the neutron and proton which resides in the nucleus, that is nucleon. Again, this is very important part of your class, very often asked in the entrance and also in the class exam. And these are things: isotopes, isobar, isotone, isodiaphers, isoelectronic species, isosters. So these are very simple and very important, and you need to know. Here is the isotopes. These are the species different. These are the species with same atomic number but different mass numbers. So one, just I have taken one H1, one H2. This is proton is 111. That is atomic number is the same. Atomic number is the same, but mass number is the different. The species having same atomic number, different mass number, same atomic number with different mass numbers are called isotopes. So this is also called protium, it is deuterium, and it is tritium. There is a difference of the neutron. In entrance exam very often comes which of the isotopes of the hydrogen have higher number of the neutron. Here number of neutron equal to mass number minus atomic number. 1 minus 1 equal to 0. Mass number minus 1 is the neutron number. 2 minus 1 equal to 1 neutron. 3 minus 1 equal to 2 neutron. So in tritium number of neutron is more. So neutron is equal to A minus Z. A minus Z is equal to number of neutrons. So number of neutron is tritium is more. So another isotopes, example of isotopes is uranium 235 and uranium 238. These atomic number are the same and mass number is the different. Very simple. So next one is isobar. Isobar is the different atomic number. Species with different atomic number means different species with same mass number. So here potassium and calcium, such 19 and 20 atomic numbers are the different, but mass number is equal to 40 and 40. If the mass number is the same and the different atomic number and the species of the difference are called the isobars. Now what is isotone? Isotones means neutron number the same. The species having same number of neutrons are called isotones. So if you take example of silicon and phosphorus, you just minus this one, A minus Z, you find out M minus Z is equal to neutron, M minus Z is equal to neutron, you will find the number of neutron is the same in the two species. Hence if the two species having same number of neutrons are called isotones. Isodiaphers, it is a new thing. I probably many of the books this term is not mentioned or not given, so I have given very often asked in the entrance exam. Isodiaphers means the species which A minus twice Z, atomic mass number minus twice of atomic number. You find out what is this number, and if both the species or three species which have A minus twice Z is equal to same, then these two species are called isodiaphers. A minus twice Z is same. A means atomic number and A means mass number minus twice of atomic number. You find out what is the result. A minus twice of 20. You find out the result of this. You will find these two has the same uranium and thorium. This has same A minus twice Z is the same. Hence these two species are called isodiaphers. Now isoelectronic species with same number the electron. Simple case I have, you can calculate yourself. There is nothing to explain much and elaborate. F negative means fluid in fluid is atomic number 9 when a negative sign, that is it has 10 electron, and magnesium 2 positive means atomic number is equal to 12. Atomic number is equal to 12. 10 minus 12 is equal to, it has lost 2 electron means 10 electron. Here also 10 electron. 1 electron negative sign means it is 1 electron is more. That is atomic number is 9 and 1 electron means atomic number is 9. Now 9 number of proton and 9 number of electrons. Am I right? 9 number of electron. So when 1 electron is added to it, so number of electron has become 10. Now here atomic number is 12 means proton is 12 means electron is equal to 12. So 2 plus means 2 minus electron. So 12 minus 2 is equal to 10 electrons. So in the both the species we have seen the number of the electron in the two species are the same, hence they are called isoelectronic species. Again this is very important. Isosters, again it is very uncommon, I may not know this one. It means that number of the atom in the molecules are the same, so also number of electrons in the molecules are also same. Say here nitrogen, there is number of atom 2, the number of atom is 2, nitrogen is there, number of atom 1 and 2, there is 2, so atom number is the same. So now what is the electrons? Say it is 14, one carbon equal to 1 nitrogen equal to 14, other nitrogen equal to 14, and 2 14 gives you 18 electron, and here 1 carbon is equal to 12 and 1 oxygen equal to 16 is equal to again 28 electrons. So number of atom and some number of electron, if the two species have the same, then these two species called isosters. Very often you will come across this term. That this term is very often may not known to you. That is atomic spectra, molecular spectrum, a lots of term of spectra. You will get it later on. So beforehand, I am just coming to the point. What is atomic spectra actually? What does atomic spectra actually means? Atom means atom, atom. From the atom, there will be a spectra. How does it appear? Means atomic spectra is nothing but the impression produced in photographic film. In a photographic film, an impression is taken, impression is found, impression is produced. When radiation of a particular wavelength is analyzed in prism, when radiation is made in a particular wavelength and it is analyzed in a prism, there will be some splitting, okay, and this will give you atomic spectra. So atomic spectra is nothing but impression produced in the photographic plane when radiation of particular wavelength is analyzed in prism. Emission spectra may be divided into three parts. One is line emission spectra, again it is very important what type of a spectra gives what. So the emission spectra means continuous emission spectra, band emission spectra, line emission spectra. Continuous emission spectra is found only in case of heavenly bodies, and band emission spectra is found from any molecule, methane like this molecule, and line emission spectra is found from atomic species. In IIT exam, a question was asked that neon line bulb in the street light, the spectra obtained is of different types. Answer: it is neon is an atom, so atom will give you line emission spectra. So these are very simple things, you should read it out, otherwise from where a question very often asks from this part or from any line of the explanation. So you follow the example: continuous from the heavenly bodies, band from any molecule, and line spectra from any atomic species. Now, if you talk about the absorption spectra, now what is absorption spectra? I am telling the definition orally. When the spectra of a species is made to pass through some substance or some media, some particular wavelength is absorbed by the media or the substance. So the spectra of remaining wavelength without the absorbing spectra is called absorption spectra. When the spectra of a particular species is made to pass through any media or substance absorbs some wavelengths, then the spectra of the remaining wavelength without the absorbed wavelength is called absorption spectra. Absorption spectra are of three types: continuous, just you add absorption term, continuous absorption, band absorption, Very simple. The continuous absorption spectra, the radiation absorbed by the green leaf is continuous. Example of continuous absorption spectra, band absorption spectra is the radiation absorbed by any molecule, and the line absorption spectra is the spectra or the radiation absorbed by a atomic species. Very simple. This is all about the spectra. So now, after discussion on the spectra, let us come to hydrogen spectra. Very simple thing, and a lot of things will be depending upon this hydrogen spectra. A lot of questions are there. First of all, you should know what actually hydrogen spectra means. The spectra, when electric discharge is passed through hydrogen gas at low temperature, what's happened, a bluish light emitted, and when this light is analyzed through prism, spectra appears, and this spectra is called hydrogen spectra. So you may ask why there is a question of spectra or spectral lines. A lots of fine line appears because hydrogen has only one electron. Am I right? So there is only one electron. What is the reason of the cause of the spectra when it is analyzed in the prism, when the fine line structures appears when electric discharge is passed through hydrogen gas? Am I right? Means in hydrogen one electron is there, atomic stage of hydrogen one electron is there. When electric discharge is passed through it, so in the atomic state of hydrogen, one electron jumps from this ground state, this next stage. A lot of stages, energy levels are there. It jumps to the higher energy level, and after some time, this electron, which on observing amount of energy of excited state, absorbing some amount of energy from ground state, it jumps to the higher and higher energy states, and after some time it releases out the absorbed energy and comes back to its original position. And during this, you will get it later on, we get change in energy is equal to h nu, and that h nu is equal to c by lambda, and c is associated with the wavelengths. There is a lot of lines appears due to the emission of energy when it's comes from excited state to the ground state. This is the cause of productions of spectra in hydrogen. So if you tell about, we know nu bar is equal to 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square, where r is equal to Rickenbach constants is SI unit is there, value is there, and CGS value is there. So nu bar is equal to wave number. We will get it later on once again, because E is equal to h c by E equal to h nu, and nu is equal to c by lambda, and h c into 1 by lambda. 1 by lambda is equal to nu bar. This is nu bar, this is wave number. Am I right? So wave number is equal to 1 by lambda. So energy is equal to h nu is equal to h c by lambda is equal to h c equal to 1 by lambda. 1 by lambda is equal to nu bar. Nu bar equal to wave number. Am I right? So new wave number is equal to 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square, where r is called Rickenbach constant. Am I right? Where from this formula came? It is a bit lengthy process. I am not going to show you, but I am showing you the some process where there is what is n1 and what is n2. Here actually Just I am showing you that if it is nucleus, so this is 1, this is 2, ground state 2, this is 3, this is 4, this is 5, like this. Am I right? So on jumping in excited state, electron may be in the any position, any energy level. So from that energy level, it will come back to its initial position. Am I right? So on jumping, say it is in the last energy state, say 5, I have assumed here. From 5 to 1, if it is nucleus, am I right? From, say it is 1 2 3 4 5 6, I have assumed in this way. So from the last 6 to 1, 5 to 1, 4 to 1, 3 to 1, 2 to 1, here n1 is equal to 1. That is the radiation, that is the electron is coming back from which level to which level. Ultimately the level in which it has fallen is called n1. It is fallen on n1. Here n1 is equal to 1. And from which level it is jumping, either from 2 or from 3 or from 4 or from 5 or from 6 or from like that. So here n1 is equal to 1 and n2 is equal to from 2 3 4 5 dot 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 dot, dot like this. And that series, if these things happen, it is called Lyman series. It is called Lyman series, where n1 is equal to 1 and n2 is equal to 2 3 dot dot dot. Likewise, if we consider second case, where electron from this level jumps not to 1, it is coming back to 2, from 6 to 2, 5 to 2, 4 to 2, 3 to 2, 2 to 3 to 2. And this type is Balmer series, where n1 is equal to 2 and n2 from 3 4 5 6. Likewise, I am not showing all. Lyman, Balmer, Paschen, Beckett, Paffon. Next it is new Humphrey. So in this way you just change 1, 2 and here 2, 3, 4. You will get Lyman, Balmer, Paschen, Beckett, Paffon and Humphrey series. So there are some series in the spectra we come across. Now question very often asked in the entrance, also in the class, is that, say so in terms of the energy, when it jumps from 2 to 1, there is energy, and when it jumps from another 3 to 1, 4 to 1, 5 to 1, lambda to 1, say it is 2. As you move, is the energy level is far and far and far away, more energy is the more and more and more. Am I right? So if the two energy jumping occurs in very two adjacent energy level, that is energy is less. Adjacent energy level, if jumping occurs, then energy is less. And this is very peculiar question, very often asked in the entrance. And if the electron jumps from the infinity, means energy from infinity, energy is high. Now question occurs, what is lambda related, wavelength related? We know E is equal to h nu equal to hc by lambda, that is E inversely proportional to lambda. If energy is less, wavelength is lambda is more, or maximum. And if energy is high, lambda is minimum. If energy is more, lambda is less. If that is from infinity 1, energy is more, means wavelength is minimum by this definition or relation. And if it jumps from any two adjacent level, energy is very less. Less the energy, more is the wavelength will be more or longest. So nearest jumping energy is longest, and from infinity to this energy is more, that is wavelength is minimum. So very often asked, when electron jumps from level 2 to 1 and from 4 to 1, what is the ratio of energy? So you keep all this constant, you make relation from 1 by lambda r into 1 by n1 n2 square, put the value of n1 and put the value of infinity, and you will get two relation, and you divide one relation by another, you will get the relation between n1 to n2 to n1 and infinity to n1. You will get two relation, and out of this you can solve out and can answer the question. So this is a very important point. This year in the physics second year neet, there is a question from the definition I am explaining now. What is electromagnetic wave or electromagnetic radiation? Same thing. It is when accelerated particle in space or vacuum coupled with electric and magnetic field perpendicular to each other and also perpendicular to the path of propagation is called electromagnetic wave. So electromagnetic waves are the waves generated from accelerated particle and propagate in space or vacuum coupled with electric and magnetic field perpendicular to each other and perpendicular to the path of propagation. So there is electric field and there is magnetic field. Am I right? Both the fields are perpendicular to each other and they are propagated in this way. This is the path of propagation, and also these two fields are perpendicular to the path of propagation of the wave. Am I right? So electromagnetic radiations, electromagnetic waves generated, produced from accelerated particle in space or vacuum, which are coupled with electric and magnetic field perpendicular to each other and also perpendicular to the path of propagation. Hence, the characteristics of electromagnetic radiation, this time it is asked, which one of the following is the characteristics of the electromagnetic radiation? Answer: accelerated particle. Means a particle should be accelerated. a particle or electron should be accelerated. When it is accelerated means there is variation of velocity. If it is in uniform motion or in a static field, it will never produce any electromagnetic radiation. It should be accelerated. Means when it is accelerated means when it moves with different velocities, when the difference in velocity occurs, so there is change in energy occurs. When there is change in energy occurs, already I have told you, and this is related to wavelength, this is related to radiation. If there is no change in energy, there will not be any radiation, because there will not be any c by lambda. So it should be accelerated means it should move with variable valencies in order to lose some amount of energy. If it is not accelerated, there will not be any loss of energy. If there is no loss of energy, there will be no nu, and if there is no nu, there is no lambda, there is no radiation. So it should be accelerated. Number one. If it is not accelerated, what happens? Acceleration. What is acceleration? Acceleration means change of velocity. See, one velocity and other velocity in change in time. Am I right? This is called acceleration. If both the velocities are the same, there is no acceleration. If there is no acceleration, it is static. If it is in a constant motion, there is no release of energy, no lambda, no nu, no electromagnetic wave. So it should be accelerated. Am I right? And second, what are the characteristics? So number one, it should be characteristic electromagnetic waves are, it should be produced from accelerated particle, accelerated particle. It can move in vacuum. Its velocity is equal to velocity of light. It has electric and magnetic field perpendicular to each other, and both the fields are perpendicular to the path of propagation. Next, electric field and magnetic field are in same phase. Am I right? And next, amplitude of electric field divided by magnetic field is equal to velocity of light, and this velocity of light is equal to 1 of mu naught epsilon naught. And the value of epsilon naught is equal to permittivity constant is equal to 8.83, 8.85 10 to the power 12 NC. And mu naught is equal to permeability constant, and its value is equal to 4 pi into 10 to the power 7 Tesla. Velocity of light, if you calculate, it will be this. So these are the some of the important characteristics of electromagnetic radiation. They produce from accelerated particle. It can move in the vacuum. Velocity is equal to the velocity of light. Electromagnetic fields are perpendicular to each other. Electromagnetic fields are the same phase. Amplitude of electric by magnetic field. Magnetic field is equal to velocity of light, and it is equal to 1 by root over mu naught epsilon naught. And these things are very often and in very elusive and elaborate manner explained in the electromagnetic wave in the physics chapter of second year. Please, if you have rich knowledge in chemistry of first year, you can very easily understand that chapter in the higher secondary second year. Electromagnetic spectra, again, it is a very important for entrance point of view. Very often in entrance question and also class occurs, means you are asked You should keep it in your mind, very often question asked. So it is in terms of increasing wavelength, cosmic ray, X-ray, gamma ray, X-ray, ultraviolet ray, visible light, infrared ray, microwave, radio. That is in terms of wavelength, a radio wave is the highest wavelength. You should keep it in your mind. And if you are asked in terms of frequency, so what is E equal to h nu is equal to hc by lambda. So frequency and lambda are inversely proportional. So the order of frequency of this rays will be reverse of this. If it is the, this is the order of frequency. If you are asked the order of wavelength, you arrange in this way, and if you are asked the order of frequency, you give it fast, you reverse it, because frequency is inversely proportional to wavelength. And if you are asked arrange in increasing order of energy, energy is related to frequency, energy is directly proportional to frequency. So whatever way the frequency is arranged, that is the same of order of the energy. So wavelength is of that order, frequency is of that order, and energy is of that order. So this is very important. So today's class is of this much. In next class I will start with Thomson model and Rutherford atomic model, Bohr atomic model. All the model will be completed in the next class. Hope you have followed the class with utmost interest. Thanks a lot for watching the class. Please don't forget to subscribe the class to get more and more updated classes.